So this is just a work through of the odd numbered problems from the core practice sheet. And we're going to go through them fairly quickly. So here we go. For the first two, we are finding amplitude. You just have to know where to look. So for amplitude, I'm going right to the front of my trig function and looking at the number that is in front there. So I'll tell you what, we'll try that one more time. Have a little pen lag. So it's this 1/7. Now it's already positive, so the absolute value doesn't change anything. But the amplitude here then is going to be 1/7. So this will be kind of a small trig graph. Down below, once again, look to the front of the trig function for the multiplier. Your amplitude is the absolute value of that number. So amplitude in this case is the number 5. Next up, finding the period of these different functions. We're dealing with sines and cosines, so you always start with a period of 2 pi, and you're going to divide by the absolute value of b. Now, b is the number in front of the theta. So going now inside the trig function. Absolute value of 5 is just 5, so what we have is 2 pi over 5. There is your period. Now, because that value is bigger than 1, right, you're going to have a graph that gets shrunk down. So that's a smaller period. Next up, we need to remember that dividing by 7 is the same as multiplying by 1/7. So the b value this time is 1/7. So 2 pi divided by the absolute value of 1/7 is the same as 2 pi times the reciprocal of 1/7. So times 7/1. So this is going to be a stretched out cosine graph that has a period of 14 pi, so 7 times longer than a typical cosine function. Next, once again, for period, I'm looking in front of the theta. So my period is 2 pi over the absolute value of 2. That's just 2, and the 2's reduce. So this sine graph will repeat itself every pi radian. And then lastly, come over here to the side for this one. Again, looking in front, we've got the 4. So 2 pi divided by the absolute value of 4, that's just 2 pi over 4. And yes, you should reduce your fraction. So a 1 and a 2. This period will be pi over 2. So once again, a compressed graph because that b value was greater than 1. I want to do the vertical shift first, only because that's so much easier. I'm looking for the number that is either added or subtracted separately off the front or the back of the trig function. So this is negative, so we're going to be shifting down 3 units. That's where your midline will be at y equals -3. Second one here, okay, that's on the back, so it's a +5, so the midline will be at y equals 5. So that is a shift up 5 units. For phase shift, you do need to make sure that you first factor what is in the parentheses in the trig function. So here, on this first one, there's not actually anything to do because there are no parentheses. All that means is this one doesn't have a phase shift. Now, I know that because if this was meant to be a horizontal shift, there would have to be parentheses around it all. If there's not, this +5 on the end is your vertical shift. And there is no plus or minus in the sine function itself, so no phase shift. For this next one, I'm going to take 2 theta minus 2/3 pi. And now, because I'm factoring out this 2, really what I'm doing is dividing by 2. So follow me here. I'm going to take this 2 pi over 3. We're going to divide it by 2. And dividing by 2, I'm dividing because that's the number in front of the theta, is the same as multiplying by 1/2. The 2's reduce. I'm left with pi over 3. So this is me just writing the factored version of what's currently in these parentheses. Once that's done, and only once that's done, do you look at your phase shift. So that's a minus, so I'm going to the right. And by how much? By pi over 3. Now, especially at the beginning here, as you're just getting used to it, graph it and look at it. Put this all into Desmos or into a handheld calculator and make sure, is this actually the cosine graph shifted to the right pi over 3 units? It's going to take a while to become comfortable with that. Next up, same thing again. I'm going to take what's in the parentheses, and we're going to divide that 3 out of everything. That's a theta. So I'm going to think to the side here, pi over 4 divided by 3, because that's what this coefficient, that's what b is. I'm going to now recognize that dividing by 3 is the same as multiplying by 1 over 3. Pi times 1 on the top, 4 times 3 on the bottom. And there is our phase shift. Okay, so that's a plus, meaning we're going to the left. How much? By pi over 12. So, I mean, I see if you agree with me. I think the trickiest thing on these is that phase shift. So more practice is going to be better for you. Okay, here it is now, just kind of doing it all at once. So for amplitude, I'm going to abbreviate that as amp. I'm looking right here. Absolute value of that 5. So my amplitude is 5. Next up, let's do period. And tell you what, because I'm dealing with in the parentheses here, let's just do our factoring part now. I'm going to rewrite what's in these parentheses. So 8 parentheses, theta plus, thinking to the side here, 3 pi over 2 divided by 8. That's going to be 3 pi over 16. All right. Now, I didn't need to do this to get the period, but we're going to have to do it later. Might as well do it now. So my period is 2 pi divided by the absolute value of that 8, which is just 2 pi over 8, and then reduce your fraction, 1 and 4, so pi over 4. So a short little period. This is going to be going up and down pretty quick. Next up, phase shift. Okay, for this we do need that factored version of the parentheses. Now for phase shift, please forgive me, I'm going to abbreviate that as PS. It's a plus, so we are moving to the left. How much? 3 pi over 16. All right, and then lastly, the vertical shift. For that, I'm checking out this number that's either, it's going to be on the back or on the front, but it's the one that's added or subtracted separately. So vertical shift is going to be up 4 units. Okay, let's go again. Amplitude. I'm looking in front of the trig function for the multiplier. The amplitude is 10. So this is going to go up 10 from the midline and down 10 from the midline. So from top to the bottom, it's going to be a whole 20 units apart. That's pretty tall. Now for the period, once again, why don't we do the factoring while we're here? So for parentheses, theta plus, and now I'm thinking off to the side, pi over 3 divided by 4, it's the same as pi over 3 times 1/4. That's going to give us pi over 12. All right, so for period, 2 pi divided by the absolute value of b, that's just 2 pi over 4. Reduce your fraction, pi over 2. For the phase shift, we already did the factoring work for that. So it's a plus, that's going to be to the left again. How much? Well, pi over 12, because we added on that pi over 12. And for vertical shift, let's look on the back. Once again, it's a plus, so we're going up 3 spots. That's where that midline will be at y equals 3. I do encourage you, check this all with a graph when you're finished. Get a sense, okay, do we in fact go up 10 and down 10 from the midline? We should. Do we in fact have something that repeats fairly quickly every pi over 2? You can set your Desmos axes to count by pi over 2s. That should make it easier to see. Is your phase shift pi over 12? There are ways to check that as well. So yeah, take advantage of the technology. And next for this one, let's see what we got. Amplitude. Now there's no number written in front of the sine function as a multiplier. That means it's a 1. So this will go up 1 and down 1 from the midline. For the period, no need to factor parentheses this time because there are no parentheses. So it's just going to be 2 pi over absolute value of 2. That's just 2 pi over 2 for a period of 1 pi. That's measuring how long for the cycle to repeat. Phase shift. Because there are no parentheses with a plus or minus, there is no phase shift. Hasn't moved left, hasn't moved right. And then lastly, vertical shift. Taking a look for the number added or subtracted either on the front or the back. This is going to be down since we have a negative 5 spots, and our midline will be at y equals negative 5. Now putting it all together in a graph form then, now here's the thing. Based on these multiple choices, you can probably figure it out just by looking at the easy stuff. But we're going to check it all and make sure that makes sense. Now when I say the easy stuff, I mean, I always like to check the vertical shift first. This means that I should be moving down 2 spots. So I'm looking for which of these have a midline at negative 2. That one does. This one does not. This one's got a midline at a height of 0. This one has a midline at a height of plus 2. This one has a midline of minus 2. Okay, so looking just at vertical shift, narrowed it down to A or D. The next easiest thing to look at, in my personal opinion, is the amplitude. So taking a look at amplitude now, in the front here, I see a 2, so my amplitude is going to be 2. So from that midline, do I in fact go up 2 and down 2? A does. As I look at D, no, that looks like it's only going up, I don't know, maybe a half, because each box here is counting 2 spaces. So it goes up by a half. Yeah, not 1. So somewhere between a half and 1, maybe. So it's not going to be letter D. It's going to be letter A. Tell you what, though, while we're here, let's check the other stuff. So let's take a look at the phase shift and the period. So rewriting the inside of these parentheses, it's going to be, so theta divided by 2 is the same as theta times a half, plus, and now 7 pi over 6, divided by 1/2. I'm dividing by that b value, is the same as 7 pi over 6 times, what would it be? 2 over 1. Flip it upside down. So reduce, and what we're left with is 7 pi over 3. Okay. Now phase shift is going to be a little bit hard to see. We will still check it, but it'll be hard to see. But the 1/2 I want to look at. So as far as a period goes, it should be 2 pi over the absolute value of a half, which is 2 pi divided by a half, which is the same as 2 pi times 2, which is 4 pi. So in looking at my cosine graph here now, I think the choice is letter A. What that means is from here at a peak to the next peak should be about 4 pi units. Well, it doesn't line up perfectly on these grid lines, but what I do see is my first purple dot is just a little bit before 2 pi. My second purple dot is just a little bit before 6 pi. So from 2 to 6, that's 3 pi, 4 pi, 5 pi, 6 pi. Yeah, that seems about right. 4 pi's to get from one to the other. So the period looks good. Now, the reason that I say the phase shift will be tough to check this time is that this is a shift to the left by 7 pi over 3. And the point I would usually want to check would be over here somewhere off the graph. So I would say this time, let's kind of trust ourselves a little bit. There are other ways to get there, but that's the sort of thing you'll delve into more deeply in pre-calculus. Okay, and then this last one, again, let's not work harder than we have to. First off, I like to check my midline. So once again, I should have a midline at -2, which means my only option here is C. Right, that was nice and easy. Let's just do a quick check, though. Make sure some other stuff checks out. So I'm looking in front of the sign. I see a 3. That means my amplitude should be 3. So from the midline, Do we go up 3? Yes. Remember, each box is counting by 2s. So I want to go up a box and a half from the midline and down a box and a half from the midline, which we do. And the period should be 2 pi divided by the absolute value of 3. So 2 pi over 3. That's tougher to check because here again, we're counting by pi over 2s. But what I know is 2 pi over 3 should be a little bit less than 1 pi, right? So from peak to peak, or from dip to dip, that distance there is something like that. Well, I mean, as I look here from 0 to pi, yeah, that looks to be about 2/3 of that distance. So I can trust there that that seems reasonable in this case. But moral of the story, don't work harder than you have to. Check your midline first because it's easy. Check your amplitude second because that's also easy. And then after that, I would look at period and phase shift.